All right, so 14 is your multiple angle one. First of all, the directions would have changed. It would have just said solve, not solve on the interval. And it looked like this. I want to isolate the tan of x over 2. So the first thing I'm going to do is add that to root 3. 6 tan x over 2 would equal to root 3. Then I want to divide by 6. Tan x over 2, this would go in 3 times, would be root 3 over 3. So before I can isolate that x over 2, I have to find the solution to this. I have to find what angles would have tangent at root 3 over 3. The root 3 over 3s are the over 6s. Tangent is positive in the first and the third quadrant. So the x over 2 would equal pi over 6 plus n pi, and x over 2 would equal 7 pi over 6 plus n pi. I have to add the interval on because it didn't give me the interval in the instructions. And with sine and cosine, it would be 2n pi, but with tangent, it's n pi. Now I would multiply everything by 2 so that I isolate that x. So it's going to cancel here. X would equal 2 goes into 6 3 times, so pi over 3. And then 2 here would be plus n pi, 2n pi. And then here it cancels. Here it goes in 3 times, and I would get 7 pi over 3 plus, also multiply it here, 2n pi. And that's where those two answers come from. So that's the multiple angle ones. Other questions? 5. Okay, so they're not squared. I can't replace. But they are in your Pythagorean identities, right? Tangent and secant are linked. So tan squared plus 1 equals secant squared. I want to square both sides of these, but if I do it as it is, you're gonna get a term that is tan secant that you can't do anything with. So I want to isolate them. I want to move one to the other side. And it doesn't matter which one you move, but obviously if I do secant, it keeps everything positive. So I would get tan of x equals root 3 plus secant x, or secant x plus root 3. Order doesn't matter. And we're typically like more used to seeing it that way. Now I would square both sides of the equation. And I get tan squared x equals secant squared x. The shortcut would be square the first one, square the last one. The square of root 3 would be 3. And then double the product. So product would be root 3 times secant times 2 would be positive 2 root 3 secant x. Good so far? Yeah, okay. Now I got to replace the tangent because I want them to be the same trig function. So tangent plus 1 equals secant squared. Then tan squared would equal secant squared minus 1. So I replace tan squared with secant squared x minus 1. Now I'm going to subtract secant squared x from both sides, and they cancel out. So then I want to move everything. I want to isolate that secant. Negative 1 equals 2 root 3 secant x plus 3. Subtract that 3. And I get negative 4 equals 2 root 3 secant. Divide by 2 root 3. And I get secant of x equals negative, this would be 2 over root 3. And secant's not on your unit circle, but its reciprocal function is cosine. So if I flip it, I would flip the other side too. I end up with cosine equals negative root 3 over 2. Go to your unit circle, and cosine is negative root 3 over 2 at 5 pi over 6 and 7 pi over 6. But because we squared both sides here, I have to check it. So I'd have to plug that back in. and check them. Five pi over 6 on your unit circle. Tangent is negative root 3 over 3. It would be here. Oh, students take calculus. So tan would be negative root 3 over 3. Minus the secant at 5 pi over 6 is the reciprocal of sine. The reciprocal of cosine. So if I flip negative root 3 over 2, I get, this would be minus a negative 2 over root 3. And I'd have to rationalize that. So this would get negative root 3 over 3 plus, because minus a negative, rationalize this, and I get 2 root 3 over 3. And we want this to equal root 3. Well, negative root 3 plus 2 root 3 equals, wait, sorry, hang on. Let me move this down. Okay, this would equal root 3 over 3. Is that the one that doesn't work? So it didn't work. When you do tangent of 7 pi over 6, I'd get, so now 7 pi over 6 is going to be a positive root 3 over 3. And the secant at 7 pi over 6, if I flip cosine, I get negative 2 over root 3. Which would be negative 2 root 3 over 3. It's not negative. It's positive. No, it is negative. Sorry, it's negative. So this becomes plus 2 root 3 over 3. God bless you. And this becomes 3 root 3 over 3, which is just root 3. And that's the one that works. So 7 pi over 6 is the one you get to keep. So we are, like I said, we're starting chapter 8, section 1. Well, we're starting chapter 8. We are doing chapter 8, section 1, which is the law of sines. This is, again, not included on next week's test, but obviously it will come after that. And law of sines is one of, if you can do a formula and you can plug in, you can do law of sines. That's the good news, okay? It's very different from the stuff, God bless you, that we just did. Law of sines is one of the ways that we can solve for angles or sides of a triangle that is not a right triangle. So there's two. We're going to learn law of sines and law of cosines, and they are both used in place of like SOHCAHTOA. If it's a right triangle, we use SOHCAHTOA. If it is not a right triangle or an oblique triangle, then we use either law of sines or law of cosines. Today we're going to do law of sines. Law of sines says that if we set up a proportion, or that we can set up a proportion with the ratio of a side to the sine of its opposite angle. So A over sine of angle A would equal B over sine of angle B would equal C over sine of angle C. And we can use this in any pairing. So I can use A and B together. I could set up that, I would be missing one of those things. I would cross multiply and divide. I can group B and C together. Again, I'd have 3 of those 4 things. I'd cross multiply and divide. Or I can group A and C together and say A over sine of A equals C over sine of C. The important things here to pay attention to, obviously the formula, but also that the lower cases stand for sides. These are your sides. And the uppercase letters are going to represent your angles. So when you're working them out, you got to be really careful. When you're giving, let's say you're giving like the solutions and it says to find the length of all the sides and all the angles. If I'm trying to find the length of A, I can write it as lowercase a. If I'm trying to find the angle, I'm going to make sure I name it angle A so that you know the difference, okay? A side length would be in length, so it doesn't have any term, but an angle measurement would it be in degrees, so you'll put the degree symbol. So you're going to use law of sines. Obviously, it's the only thing we'll know today, so you'll use it for all the examples today. But eventually, we will learn law of cosines too, and you'll need to know which one to use, either law of sines or law of cosines. And the way you know that is based on the type of information that's given. If you are given two angles and the non-included side, you're going to use law of sines. If you're given two angles and the included side, you're going to use law of cosines. If you're given two sides and the non-included angle, you're going to also use law of sines. We will learn next week, but we will learn that side angle side and side side are where we use law of cosines. All right, that's pretty much it. Now we just do the application part. So this says solve the triangle given C, and that's angle C, is 102 degrees. Angle B is 29 degrees, and side B is 28 feet. Round your answers to the nearest hundredth. So if you want to draw yourself the triangle, go for it. Label it any way you want, A, B, C, and then label what you're given. Angle C is 102 degrees here. Angle B is 29 degrees here. And side B, which would be opposite angle B, is 28. So my unknowns that I'm going to have to find are angle A, side A, and side C. So the first thing you want to identify is the one that you'd have both for. So what do you have two letters of? We have both the angle and the side length for B. That's going to be the complete ratio that you use. So I'm going to say B over the sine of angle B equals, the other one I have information about is angle C. So I'm going to say C over the sine of C. Definitely need calculators for this stuff, and we're going back to degrees. So I'm going to fill in the parts I know. Side B is 28 over the sine of angle B is 29 degrees equals side C I don't know over the sine of angle C, which is 102 degrees. And then from here, we just cross multiply and divide. So 28 times the sine of 102 is going to equal C times the sine of 29. And then I would divide. By the sine of 29. I'm going to make sure my calculator's in degrees, and then I'm going to type that in. Go to my mode, switch to degrees. 28 sine of 102. If you're going to type it all in at one time, make sure you close the parentheses after the 102. If not, you can just hit like sine 28 sine 102, hit enter, and then divide by the sine of 29. And I get 56 point, it said to round to the nearest hundredth, so I'm keeping 2 decimal places. 49. Sophia.
How do you know to like make it like that, like from a fraction? How do you make it 28 times 9?
How to cross multiply, you mean?
Oh, okay.
Yeah, when you get the proportion, you're always going to cross multiply. Okay. So fill out your proportion and then cross multiply. Okay, now I have to find angle A and side A. How could I find angle A? They all add up to 180, right? If I have two unknowns, if I don't know angle A or side A, there's no way I can set up a proportion. I need at least one of those. So there had to be another way, and in this case, it would be that the three add up to 180. So I'm going to do 180 minus 102 and 29. And I get 49, and it's an angle, so it's 49 degrees. Then I would set up a proportion with the B stuff again, and I choose B even though I've now found C. I choose B because that is what they gave me and it's not a rounded number. So always go back to the original information that they gave you. So I'm going to use B, which is 28, over the sine of B, which is 29 degrees, equals A, that's the last unknown, over the sine of angle A, which is 49 degrees. And then you cross multiply again. 28 times the sine of 49 equals A times the sine of 29. And divide both sides by the sine of 29. So 28 sine 49 divided by sine 29. And I get A equals 43.50, well, it'd be 587, so it'd be 0.59. Sophia?
How did you find it?
The angle?
Yeah.
I added these two and subtracted it from 180. So if you get two of the angles, you can just subtract them from 180. All right, let's do it again. Solve the triangle. Given A is 43 degrees, B is 98 degrees, and C is 22 feet. So A, B, C, 43 degrees, 98 degrees, side C is 22. So the catch on this one is I don't have anything for a complete ratio already. I don't have both letters, right? I don't have two A's, I don't have two B's, I don't have two C's. Do you have a way of finding something that you could use, though? Christina? How do you find angle C? Good. So I could do 180 minus 43 minus 98. And I get angle C is 39 degrees. Now I have my complete ratio. So this time I'm going to use the C's. I'm going to say 22 over the sine of angle C, which is 39, equals, I'm going to do it for A over the sine of angle A, which is 43. Sorry, I can barely tell this an A. And then I'm going to repeat the process again. 22 over the sine of 39 would equal side B over the sine of angle B, which is 98. So for both, we're going to cross multiply. And then divide. A is 23.84. That's side A. And 22 times the sine of 98 equals B times the sine of 39. And then divide both sides by sine of 39. 22 sine 98 divided by sine 39. 34.62. Law of sines formula is pretty easy. The setup is pretty easy. The catch on law of sines is something called an ambiguous case. An ambiguous case happens if you, or can happen, sorry, thank you, if you are given two sides and the non-included angle. So if it spells a bad word, forwards or backwards, if that's the information that you're given, okay, then what can happen is from that information, one triangle can be formed, just like we did already. It would be a regular one single triangle. One right triangle can be formed, which that one doesn't happen too much, but no triangle can be formed, meaning that there's no way for those measurements to form a triangle. And most annoyingly, two triangles can be formed. And this is why that happens. Like if you remember back to like geometry, okay, which was so very far away, right? A whole year. No, more than a year ago is when you would have talked about this stuff. There are 5 ways to prove triangles are congruent. Side, side, side. Side, angle, side. Angle, side, angle. Angle, angle, side. And hypotenuse leg. There are 5 ways to prove that triangles are congruent. If you are given that kinds of information, there's only one possible triangle that can be formed, okay? But notice what's not in this list, and it's not because it does spell a bad word, but if you are given 2 sides and a non-included angle, it would not be enough information to prove 2 triangles were congruent because that information can literally form 2 different triangles. So if I took the information that they gave me and it was 2 sides and the non-included angle, it's possible that that third side does not ever reach. And then it wouldn't work. That's where a no solution comes into play. It is also possible that if I'm given these 2 side lengths and this angle here, that if I swing that side in, it would look like that, the triangle I just drew. If I swing that side out, it would look like this triangle, which means 2 triangles can be formed with those measurements. So the problem is you'll never know it from the beginning. When they give you the information at the beginning, you cannot look at that information and say, oh, this is one of those that's going to have 2 triangles. There is 2 ways to find it out, and one I'm not even going to cover because it tends to confuse people. So I'll teach it this way. When you're given 2 sides in the non-included angle, so when you look at the information that's given, if you're given 2 sides in the angle that's not where they meet, then you're going to continue through the motions as if you were setting up everything else. You will use law of sines to find the missing angle. So we'll set it up like we just did in the last examples, and we're going to find an angle. That angle we will call B1 if it's angle B. If it's angle C, we'll call it C1. If it's A, we'll call it A1. And then we will go through the motions to assume that there is also a second triangle. And to do the next step, you will take and subtract what you just got from 180, and we will use that as B2 or A2 or C2, whatever that letter is you're looking for. We will continue to solve the first triangle, and then we will go to the second triangle and we will continue to solve that. So we'll solve the first one just like normal, and then we'll solve the second one. If when you go to find the third angle on the second triangle, that angle ends up being negative, then we say there's no second triangle, there's only that first triangle. If that last angle is positive, then we're going to solve it and we know it's a second triangle. So the catch here is you have to know to do this, and that is based on the information that's given. So when I look at a question like this one, it says solve the triangle. It looks just like a regular question. It's giving me 2 sides and an angle. When I draw this out, angle A, B, C, I'm given angle A, which is 42 degrees. I'm given side A, which is 22, and I'm given side B, which is 12. Notice you are given 2 sides and then the angle that is not where those sides meet. So that is the non-included angle. It could have been angle A or B, and it still would have been the non-included angle. So you're going to remind yourself that this could be an ambiguous case. So as soon as I see that I have 2 sides in the non-included angle, I make myself a note, something like that, to remind myself to check for that second triangle. So there's 3 outcomes here. No triangle, which you'll see what that looks like in a minute. 2 triangles or 1 triangle. But I start the same way I started last time. There is 1 complete ratio, right? I have both A's. So I'm going to do 22 over the sine of angle A, which is 42, equals the only other piece of information I have is side B. So I would do side B, which is 12, over the sine of angle B, which is what I don't know. Now I'm going to cross multiply. 12 times the sine of 42 would equal 22 times the sine of angle B. And I'm going to divide. This is the first time we're looking for an angle, so notice that what's left is not just B, it is the sine of B. So I'm going to like write that 12 sine 42 divided by 22, and I get 0.3649, so on and so forth. I don't want to round that. I'm going to keep it in my calculator so I can pull back that answer. But that is not the side, that's not the actual angle length, right? If I'm saying that is the sine of B, how do I actually find B? If I'm given the trig function and I'm looking for the angle, what button do I hit? The -1. So I'm going to do sine -1 of that value. Second, sine, and I'm going to pull back the answer on my calculator so it keeps it that whole thing. And I get angle B is 21.4, what's it say around 200th? So 41 degrees. But we're going to call this B1. And we're going to assume there's a second triangle. A no solution triangle right there, you won't be able to get your first angle. So if it's no solution, you'll get it right away. And it will happen because sine is bigger than 1. So if from that ratio I got sine of -1 of like 1.2, your calculator will yell at you, but also you should catch that. Sine can't be bigger than 1. So that's when a no solution happens. Jalen. Because on the other side of the equal sign, it's not just B, it's sine of B. So to get to angle B, I have to find the inverse. So now on the side, I'm going to write angle B1, and then I'm missing angle C1, and then I'm missing side C1. And then I'm going to duplicate all of that for my second triangle. Angle B2, angle C2, and side C2. So the first thing I just found is B1 is 21.41 degrees. Yeah.
Wait, how do you know again that there's two triangles?
You don't know yet. You assume that there's two triangles if the information given to you is two sides and the non-included angle. So we're going to assume it until I'll show you, like, this is the step where you'd know. We're not there yet. So I can continue to finish out the first triangle. I would find angle C1 by doing 180 minus the A that they gave me, which is 42, minus the B I just found, which is 21.41. And I get angle C1 is 116.59. And then the last thing I need to find from my first triangle is side C. So I always go back to the complete ratio I used from the information they gave me, which was the A's. 22 over the sine of 42 would equal side C1 over the sine of angle C1, which we just found was 116.59. And I get 22 times the sine of 116.59 equals C1 times the sine of 42. And this time I divide by the sine of 42. So 22 sine 116.59 divided by the sine of 42. And I get C1 is 29.40. So I completed that whole first triangle, and again, if you don't know to check for your ambiguous case, you'll think you're done, you'll move on, and you could miss possibly a whole second triangle. Once you have that first triangle, you have to form the second triangle with the first angle you found on the first one. So the first one I found was B1, and it was 21.41. So then I find B2 by doing 180 minus that. So 180 minus 21.41 gives me 158.59 degrees. So now I'm going to use the triangle with all the original information. I would say angle A is still 42 degrees. I would say side B is still 12 and side A is still 22. That information is still the same. But now I'm making B2 158.59 degrees. Now the last angle I have to find is C2. I would have to do 180 minus the A they originally gave me, minus the 158.59. What happens if I do that? It's going to be negative, specifically negative 158.59, negative 20.59. If that third angle is negative, then I rule out my second triangle, and this scenario just has the first triangle. If that angle was positive, now I know there's a second triangle, and I would finish it out. I would then find that last side. So remember, there's three scenarios. One triangle, which is what we just did. No triangles, in which you would get an error here at the very first angle, or two triangles where the angle we just got would have been positive, and then you would have solved the remaining side. We're going to do it again. Set up your triangle. A, B, C. What's given to you is side A is 15, side B is 25, and angle A is 85 degrees. So side, angle here. Two sides in the non-included angle, which means ambiguous case. Which letters do you have both of? A's. So I'm going to use that all the time. 15 over the sine of 85 is going to equal, the only other one I have information for is B. Side B, which is 25 over the sine of angle B, but we're going to call it B1. Cross, multiply. And divide. And sine of that is what you're finding. So I'm actually going to do it all in one step. I'm going to do sine -1. And I'm going to put that whole thing in there. So second sine 25 times the sine of 85 divided by 15. Make sure you close the parentheses after the 85. What happens? It's going to say sine -1. If I had worked that out, it's 1.4. What's wrong with that? Can you find an angle if the sine is 1.4? No, sine can't exist bigger than 1. So this is what it looks like when there's no triangle. Those are the ones you really hope you get because you're done. You don't have to do any more work. Jalen. Yeah, it should. Because it's not possible. 25 sine of, I typed it in wrong. 25 sine of 85, I put 58. Divided by 15. I got lucky that it was still, it should have been 1.66. This, sorry. 6. It still gave me an error. Questions on that one? All right, one more. So set it up again. A, B, C, angle A, 20.5. Side A, 12, side B, 31. And again, I have both A's. So 12 over the sine of 20.5 equals 31 over the sine of B, we're going to call it B1. Cross multiply. 12 times the sine of B1 equals 31 times the sine of 20.5. And then divide both sides by 12. I'm going to do sine -1 of that whole thing. And I get angle B1 is 64.78 degrees. So I'm going to continue on. I still need to find angle C1 and side C1. And then I'm going to assume, until we prove ourselves wrong, that there is a second triangle. So staying on my first triangle, the next thing I would find is angle C1. I would do 180 minus the other two, so minus 20.5 and 64.78. And I get C1 equals 94.72. And then the last thing I want to find from the first triangle is side C1. So I'm still using the A's. 12 over the sine of 20.5 equals side C1 over the sine of angle C1, which is 94.72. Cross multiply. And divide. Sine 94.72. Make sure you close the parentheses. Divided by sine of 20.5. And I get 34.15. Questions so far? Okay, then I'm going to go to my second triangle. And the way I find B2 is by doing 180 minus B1, which is 64.78. So 180 minus 64.78, and I get 115.22. So I only subtract B1 from 180 to get the second triangle's angle. Then to find C2, I have to do 180 minus the other two angles. So now we're saying this is 115.22. So I would do 180 minus the 20.5 that was originally there, minus 115.22. And last time that was negative, and that's when I knew to stop. This time it's not negative, 44.28, which tells me there is a second triangle. And now I've got to finish it out by finding side C2. So I still go back to the original information that was given for the A's, 12, because that's true for both triangles. 12 over the sine of 20.5 would equal side C2 over the sine of angle C2, which is 44.28. 12 times the sine of 44.28 equals C2 times the sine of 20.5, and then divide both sides by the sine of 20.5. Sine 44.28 divided by the sine of 20.5. And there's the last side. So in an ambiguous case with two triangles, you're going to have 6 parts to your answers. You're going to have the angles and the sides for the first one, and you're going to have the angles and the sides for the second one. What the information that's given to you is true for both triangles. questions? So again, we'll practice this again like after your test. So next Thursday, we'll practice it again. And there is one more, we'll do the examples there, but there is one more thing in this section, and it is the easiest part, to be honest. So the area of the oblique triangle, so like let's say it's not a triangle in which it's equilateral, which maybe you can remember how to find that from geometry, or a triangle in which you have the base and the height. How else would you find the area? And these are the formulas. Notice it's a pattern. It is if you're given two sides and the included angle, that's what you would use. And it is 1/2 the product of the two sides times the sine of the angle that's given. So as long, you have like one of each letter, basically. And then if you're given side AB, then you would use angle C. If you're given side AC, then you would use sine of angle B. So it's 1/2 the product of the sides times the sine of the angle. And it will literally give you exactly that. So I'm just going to do the first one, and then we'll go back to the next one next week. It says find the area rounded 2 decimal places. So I'm given B, A, and C, one of each letter, 2 sides, and the angle. So I just do 1/2 A, B, sine of angle C. 1/2, A is 90, B is 52, and the sine of angle C, which is 120. And then let the calculator do the work. Like 0.5 or 1/2 times 90 times 52 times the sine of 102. And you get 2288.87. It's 865, so it'd be 87. And it would be meters squared because it's area. Literally just plug it in, okay? Again, we'll go back to B next week. So we'll do those extra examples and we'll do B next week. And this homework won't be due until after your test. But it needs to at least look familiar when we come back to it. Yeah.